So I'll just read it more formally. So Eric is a chief algorithms officer at Stitch Fix, a fashion retail company of $1 billion in sales that was built from the ground up to take advantage of data science and AI. And that's what he's going to tell you about today and maybe more. Eric's teams of 85 plus data scientists applies hundreds of algorithms, nearly every function of the company: merchandising, inventory, marketing, forecasting, operations, logistics, and their styling recommender system. Styling is really human in the loop kind of algorithms, and it's really fascinating. He and Eric himself and some of his employees came to give lectures, guest lectures in my class, and I envy you now. Prior to Stitch Fix, Eric was VP of Data Science and Engineering and Netflix, where he was early part of the recommendations platform presented here by Tony Jabara from Netflix last year. As I mentioned, he graduated here from MSNE and the Masters, advised by Ramesh Johari, and he keeps on contributing continuously to MSNE. He also has ties with ICME, where he collaborated in the past few years, where he was part of an ICME panel in spring 2018 of unintended consequences of AI. So without further ado, we're happy to have Eric. Thanks.
Thank you. All right. Well, I thought I'd set some expectations of how we're going to spend the next hour. Let's see. I'm hearing buttons. Hold on. There we go. You're right. I was pushing up. OK. Expectations. I'm going to do 2 mini talks in here. I've shortened other talks I've given just to condense them down. I got some advice from Karen on what you all might be interested in, so I think these will cover them. So mini talk number 1 is differentiating by data science. And in that, I'll do a demo of this thing called the algorithms tour. I'll show you a bunch of real-life applications of how we're using AI and machine learning to solve real business problems. And then mini talk number 2 gets a little more philosophical, talking about humans and machines working together. And then we'll stop. We'll do lots of Q&A. OK. So I went up. There we go. Differentiation. So all successful businesses differentiate by one or more of these mechanisms, right? They need something that gives them an advantage versus the competition, something that will allow them to command superior returns, and those have to be sustainable. And one relatively new way is through data science. So with the availability of new data sources, the company that can better take advantage of that data is going to have an advantage, and it can differentiate itself through a new mechanism, data science. So I happen to work for one such company, Stitch Fix. So by show of hands, how many have heard of Stitch Fix? All right, it's getting pretty ubiquitous. All right. If you don't know what Stitch Fix is, it's an apparel retailer. We buy clothes at wholesale. We sell them at retail prices. So it's the same business model that has existed for hundreds of years, but with a little bit of a twist, and that is the customer experience. You don't shop for things at Stitch Fix. There's no online browsing or search boxes or even recommendations on the site or in the app. Instead, you put in your preferences, and we call ourselves a styling service. We'll send things to your home, and that's the first time you're going to see them. You can try them on in the privacy of your own home, and you can decide whether you like them or not. Of course, you only pay for what you say you love and going to keep, and we pay for the shipping both ways. So it's a very different way to do things, but you can still say we compete with other e-commerce and retail sites. So from the very beginning, we had to define how are we going to differentiate ourselves. And there's some traditional ways to do this. Price is one, right? You can be the low price leader. But we decided, we're not going to do that. We're going to be a full price model. We do no sales at Stitch Fix, no discounts, no promotions, no markdowns, right? So we're full price model. So we don't differentiate on price. We could have chose fast shipping like Amazon, right? But we don't. You're not going to get a shipment in same-day shipment or even next-day shipment from Stitch Fix. We take about a week to get your shipment. So we don't differentiate through speed, and we don't differentiate through brand. A lot of retailers, like Prada is a great example, they differentiate through brand. People will pay 10 times more for something because it says Prada on it, right? And it's more or less the same bag or shoes or whatever. So nobody's going to pay anything extra because it's coming from Stitch Fix. That wasn't our positioning. So we ruled those out from the beginning. And we say, how are we going to differentiate? How are we going to be better than the competition? So certainly there's a new convenient way to shop. The stuff comes to your house. But it had to be more than that because we expect copycats. And we said we're going to differentiate by data science, right? We have an advantage. I mentioned the availability of new data sources can give you an advantage. And we have a new data source. Particularly, this model where the customer's not picking out, they're not doing the shopping on their own, this affords new data. So that's a client, and they tell us a lot of things about themselves, things like this, their height and age and weight and preferences for style and fit and all that kind of stuff. And it makes sense that they tell us this. They say, well, if you're going to do the shopping for me, I better share something about myself. Here's my height and age and weight and all that kind of stuff. It makes sense that they would provide this so that we can do a better job for them. And this is really special. Even I underestimated the power of this data. I worked at Netflix for 6 years, and we don't know anything about our customers, hardly. We know their viewing history. That's about it. But we don't know their gender. We don't know their age or any of that stuff. They don't tell us. There's no incentive to tell us. But here with Stitch Fix, by taking away their ability to choose, they surrender this information to us, right? They're saying, well, you better know how tall I am if you're going to pick out a shirt for me, right? So it makes sense that all of a sudden this data comes to us and it gives us a little bit of an advantage. We'll talk about what we can do with this data in a few minutes. So that's one of our 3 data sets. The next one is merchandise data. I'd say a little less unique to us, but we're very disciplined about it. We collect a lot of data on each piece of merchandise. We get a sample of everything sent to our headquarters so we can measure the heck out of it, and we can have models try it on. We record somewhere between 30 and 50 attributes of information, depending on the type of merchandise. This being a men's shirt, there's some of them. We actually record lots of different points of measurement all up and down the shirt. Even there's one up there saying the distance to the first button. How many inches is it to the first button, right? These things are important when you're deciding who to match it to. And so all this merchandise data is another thing that we have going for us that I wouldn't say it's as exclusive, right? You can see where the client data comes to us where other retailers don't because they have to. I guess other retailers could collect this data, but they tend to not have the incentive to do so. We need to. All right, but the third set of data is right here in the middle called feedback data. What we do is we expose shirts like that to clients like this, and we see how they interact. We send it to his home, and we get him to try it on, and he tells us what he thinks of it. And he does this in a pretty structured way. There's a little form that looks like this. First, he'll tell us if he's going to buy it or not, and then he'll tell us what he thought of the size, the price, the style, and the fit. And he can get very specific. You can see there, he can tell us if there was a problem with fit. Was it the chest or was it the shoulders? What was it, right? We need to know. So this is really interesting that we're able to collect this data by purposely exposing clients to different sets of merchandise. So we send that shirt, we send them other shirts, we send the same shirt to other clients, and we get a lot of feedback data. Now, the 3 really interesting properties about this feedback data, or actually it's 4. I've updated this slide recently. So it's 4 sort of exclusive properties. One is it's less biased. So we're getting data on, we got that guy to respond to that shirt, and he didn't pick it out. So this is different. When we shop for ourselves, we're a little bit more narrow-minded on what might be good for us. We close ourselves off to other things. But when somebody else picks it out for you, well, it's in my home now, I guess I'm going to try it on. And you're often surprised that this thing that you thought you would never wear in a million years, you saw something like that in the store, it's just not for me. When it got sent and put in your home, you try it on, you might think otherwise, right? So this is different. It's a less biased data set. It's not just things you picked out for yourself, but we've broadened your consideration set. Very important to do this, by the way, because you can discern things that are owing to the client versus things that owe to the merchandise. For example, suppose we bought 1,000 of that shirt, and we sent them to our best clients, and they all got purchased. We said, well, what a great shirt that was. Well, how do we know it wasn't the clients? I just said it was our best clients. They probably would have bought anything we've thrown at them, right? So, but by allowing, we control the interactions, who gets exposed to what, we can induce some variation, to be able to discern whether it was the client or the shirt, what is making it special here. So this is a very important thing that we were able to reveal. All right, so less biased data. We get both the positive and the negative feedback. This is important as well. Think about a brick and mortar store. They get a record for everything that was tried on and then brought up to the cash register and they bought it. But for the things that went into the dressing room and they didn't work out and they got put back onto the shelf, there's no record of that. And that's important. You need to know not just that that happened, but why. Was it too tight in the shoulders, too tight in the chest, whatever. So we get records on everything, the good and the bad. And I swear, sometimes the bad is more valuable than the good. Knowing what doesn't work for somebody gets you to know them better than stuff that does. So very important you get the good and the bad. The next, it's thoughtful. Again, we're not showing this to you in an app, and you're not doing kind of mindless Tinder swiping, yes, no, left, right? This is put in your home, and you've tried it on, and you've seen what it looked like on your body. That's important. We're not interested in averages here. We want to know specifically how that thing looked on you, and we want that feedback about shoulders and arms and all that stuff. And then finally, it enables network effects. So when we learn about one client, what works with them, we get to apply those learnings to other clients. And clients don't usually know this, but they benefit from other clients because we learn from them and apply the learnings to them, so forth. So very special properties about this data. Okay, so what can we do with this data? Well, we now have algorithms running in every function in our company. Like Atay said, we have to update that number. We have over 100 algorithm developers now in the company. And most people think of us as doing this recommendation engine, and that's true. But there's only about 7 people that work on the recommendation engine. The other 93 algorithm developers are working on other things like this. We have inventory management algorithms, buying algorithms, planning algorithms. We have algorithms that are designing some of the clothes now. And so, well, this is the demo portion. So I'm going to show you something called the algorithms tour. And this is a good thing you can look on your own. It's a public document. And it'll talk about 10 of the algorithms we're using at Stitch Fix. And only 10. There's a lot more than that. But these are ones we thought that were easy to articulate. OK, so you can do this on your own. This is algorithmstour.stitchfix.com. And there's a little bit of a narrative to this, and it's kind of a linear flow. It's supposed to be kind of a journey through Stitch Fix, but I'm going to do it slightly less linear. So the algorithms are listed here on the left-hand side, and you can hop around. Each one is self-contained. But I'm going to start here. I'll back up a little bit. So this is our business model in a nutshell. We sort of present it as a two-sided network where there's clothes on one side, clients on the other, and we're the matchmaker in between. It's not quite a two-sided network because we actually own the inventory. We do take possession of it. But what we're capturing here is, or showing here, is that we're capturing this rich client data. Right before they even engage with us, they're telling us all that stuff about themselves: height, weight, age, preferences for style and fit. And then likewise, we're collecting all the data on the merchandise. Okay. So one of the first things that happens after you get through that sign-up flow is, this is our client, and she says, we have all her client information. We're storing it as like a vector here. And she picks a date. I want a shipment on Valentine's Day, February 14th. One of the first things we need to decide is which warehouse the server had her. She lives here, and we have 5 warehouses. Right? So it makes a difference which ones you pick, both in shipping costs, the cycle time of the inventory being out, and the chances of success with her. There's different inventory at different warehouses, right? It's not all exactly the same. And so we try to minimize shipping costs, but we'll also happily pay extra shipping if we can get her better merchandise, if there's better things for her at one of these warehouses. So it becomes a pretty complex problem. So we have an algorithm for that. So what happens is you might recognize this as a constrained optimization problem, and indeed it looks like it's straight out of a textbook, and it kind of was. These things are not just theory. You can really put them into production and make a big difference in a company. So here what we're doing is we frame this up as a matrix of clients and warehouses. Right? We have millions of clients and about 7 or 8 warehouses now. And in the body of this matrix, we're putting a cost function. Never mind how that was derived, but right now, what you want to do is minimize that cost subject to certain constraints, right? So the constraints are every client has to get assigned to a warehouse, and no warehouse can go over its capacity. And then you merely need to optimize that problem by doing the assignments, the optimal assignments. So this is one of our earlier forays into operations. We've now done a lot more in there, but this makes a big difference in reducing cost or providing a better client experience. So we had an algorithm take that on. It used to be a different process, and we replaced it with an algorithm. Okay, moving on. So now that we've assigned that client to a warehouse, it's time to style her. Now we have styling algorithms. This is the process that picks out the clothes for her. And it's actually composed of distributed resources. So we got machines and humans. Humans, they're stylists. We think of them as human compute resources. They do tasks that our machines are not so good at. And so we leverage both of them in our styling algorithm. So first we start with machines. And one of their jobs is to eliminate things from candidacy, things that are not the client's size, or maybe they're things she's had in the past, or colors that she hates. We'll just eliminate them, no matter how relevant the other qualities are. So that eliminates a lot of things. And then what we do is we take what's left over, we run them through actually a number of algorithms, not just one, but a lot of different things that we're trying. There's the matrix completion style algorithms, things like Amazon's. People who like this also liked that. We do those. They don't work very well in apparel. The matrices are too sparse. They work better for durable products like books, music, video. But we do use them when we have opportunity to do so. So clients with long histories and they overlap with other clients with long histories, then maybe they'll work. Our main workhorse is mixed effects models. This is a type of model that captures interactions between the products and, attributes of the products and attributes of the clients. And these are strikingly appropriate for the type of problem we're working on, so that we use those a lot. But we also use, this one is an interesting little thing we call latent style. We have to find people's true styles. So there's a spectrum here of small, medium, large for sizing. There's no standards in retail sizing. You can do whatever you want if you're a brand. And so they confuse the consumer. You may be size medium in one brand and size large in another, et cetera. So what we do is we just treat it as a latent variable, and we'll figure out where each client lands on the spectrum and each piece of merchandise lands, regardless of what the label says or regardless of what the client reported they were. So, and you can see that we're making it more of a continuous range. Medium is a wide spectrum. This dress might be on the big side of medium, or it could be on the small side of medium. Same thing for clients. And so what we're trying to do here is match them up with short lines. We minimize the distances between the merchandise and the client. You don't want long lines that stretch across here. That won't be a good fit. You want short lines. So we're deriving size. What our aspiration is to one day rip all the labels out of the merchandise and replace them with a single label that says size U, Y-O-U for you, and say, don't worry about it, we know your size, this will fit you. Because right now we have to break size barriers. We have to say, I know you said you're a medium, but we're sending you a small. It'll fit you, trust us. So this has been a big boon for us, is to figure these things out. All right, we also have more exotic algorithms, computer vision algorithms that digest people's Pinterest boards. It's hard for a client to express in words what they like. It's easy for them to poke and pin pictures. And so when they make us a pin board, we'll digest it with machines and figure out what's the closest thing in our inventory that we have to that thing that they pinned. Sometimes they pin exactly something we own, and we'll recommend that up. So there's some computer vision stuff using deep learning. We do some natural language processing. People write little notes. This client says, I need something to wear to a casual outdoor wedding. And the algorithms will do something pretty clever here. They look through all of our history to find pieces of merchandise that clients have made a comment about that. They said, well, this was great. I wore it to a barbecue and then over to a bar mitzvah or something. You know, having that same connotation, they didn't use any of the same words, but that casual, but you can get away with wearing it to a semi-formal event type of thing. And that might be a good recommendation for this client, right? So that's a cool thing about machines. They can do this in milliseconds, run through millions of past fixes to find matches. All right, moving on. Once the machines are done, they rank order everything and say, here's a bunch of recommendations. And we don't give them to the client just yet. We first have a human layer his or her judgment on that too. These are professionally trained stylists that do things that the machines are not so great at. We'll talk about that a little bit, so I'll kind of skip that. But we do have another algorithm that picks which human works on this shipment. So machines are all the same, they're homogeneous. You pick anyone. But for humans, you want to be careful which one you assign to this client. They have different preferences, and you want to leverage those preferences and match them accordingly. So we have an algorithm that picks which human, and then, so that's the algorithm. Looks like the other one, constrained optimization again. But it picks this one. And it will render those machine-generated results in this interface to this stylist. And we log everything that happens in an interface because we need to learn how humans make their decisions. We need to know which information helps their decision and which information hurts. Sometimes you can show them too much information and that actually leads them down the wrong path. So we're careful with what we show. And so we're logging how long it takes them to make their decisions. We're logging how carefully do they follow the recommendations, or do they skip to the bottom, overriding the recommendations? Do they apply filters? How long does it take? All that kind of stuff. Let's see. So our human stylist will write a little note back, and then it's off to the warehouse for pick, pack, and ship. So warehouses are big. We have several of them, and they get to be big. There's a job in the warehouse called a picker. They take a pack slip, all the things that are going to go out into the shipment, and they have to go pick them, right? And we've learned that our pickers were walking, I can't tell the exact numbers, but around 10 miles a day around the warehouse picking things. And we figured out that if we have an algorithm optimize their walking path, that this could greatly reduce their walking time. And we successfully did that. We knocked it down quite a bit using the traveling salesman problem with a heuristic. Of course, we didn't solve the traveling salesman problem. But we did simplify it, and we were able to get that walking time down quite a bit. So there's an algorithm that helps the picker navigate through the warehouse. Once the clothes are picked, they get shipped out to the client. She reads this little note, and then she looks at the clothes and tries them on, and she decides that she's going to keep these 3. They're going into her closet, and 2 go back to the warehouse, right? And you see that little dot going out that way to the right? That's the feedback I mentioned. That's our goal. That's our bread and butter that allows us to derive nearly everything you're going to see here today is derived from that feedback data. Again, exposing different pieces of merchandise to different clients gets us wonderful data, and we can do a lot with that. Okay, so the process continues, not just with one client, but with lots of clients. We learn from each other. We use these hierarchical models so we can share learnings across the clients. And we have this big cycle happening. Cycle of learning is what we call it, and it's also nice that it's profitable. You see fewer things are coming back than are going out. And we keep going. That's a client, and going through different stages of life, or we call them states. So in the beginning, clients are always look like that. They say, I'm excited to start, and they have a depleted closet, as you can see up there. Then after using Stitch Fix for a while, they tend to start filling up their closet, and then they tend to get more specific in their needs. Okay, well, I have enough general stuff. Now I need something for that outdoor wedding. And then sometimes this happens where my closet's getting full, and they may actually slow down. And we need to detect all these states because obviously we want to engage with the client differently depending on where she is. A client here is going to need more clothes than a client who's here. So we detect all these states. To do that, we use Markov chains. First, we do this time series thing, and then these are supposed to be those 3 states, and you can see the clients transitioning from state to state. And why do we do this? Well, we need to know demand. And what better way to predict demand than using our clients and what state they're in? Again, the clients in one state are more likely to get more shipments than a client in another state. And so what we do is we project those out to weeks and quarters, or weeks, months, quarters, years, and so forth. And then we plan our demand. With a good, accurate forecast of demand, we can now buy commensurate inventory. We can hire the right number of stylists, the right number of warehouse workers, the right number of customer service reps, right? So all this is driven off of a Markov chain that is very accurate, actually, and allows it. It's such a huge advantage to have a predictable business. It's something I learned coming into Stitch Fix. I didn't have much prior retail experience, but for retailers, having a predictable business is so important. Not just predictable, but non-volatile too. We're pretty steady Betty on our stuff. We don't have what's happening now at Black Friday last week, whenever it was, where retailers ride in the red all year until Black Friday, then they do like 4 times their normal volume in the last month of the year. We don't have that. We're pretty steady, which is really nice because then you can set your capacity. You can set your capacity at a normal level, not 4 times too big for most of the year, and then you have too much in one part of the year and not enough. So big advantage. Okay, moving on. So I mentioned we forecast demand using these Markov chains in order to get enough inventory. And then we manage the inventory using a lot of operations research methods, right? Again, it looks like it's straight out of a textbook, and it is. And our data is so well behaved that you can actually implement these things almost directly. So these are called QT models. If you've taken operation research, they predict the optimal cadence of reordering merchandise. And this is the inventory flowing into our warehouse. And again, we don't just have one warehouse, we have many. So we have an algorithm that allocates between them, right? And this is very important. Not all warehouses are going to go through their inventory at the same rate. You need to predict how responsive each warehouse is to each particular type of clothing and stock them appropriately. We also have an algorithm that looks for clothes that are no longer relevant and pulls them out, and we donate them. So that's a very important thing to do, too, is you want to get rid of your stale inventory. We have algorithms that will do that. Skip down to here. I mentioned the algorithms designing the clothes. How this works is we break down pieces of merchandise, or styles, as we call them, into their component parts. So this blouse has a neckline, a sleeve type, a pattern, color, some dimensions, a hemline, etc. Okay, so we classify, we break them apart into all these different elements, or attributes, and each of these attributes has, some finite number of values it can take on. Like there's probably 10 different necklines and 15 different sleeve types and so forth. But if you multiply all those together, all the different attributes times the number of values it can take on, you get a number that's in the trillions. It gets very vast very quickly. So what we do is we use algorithms to search through that space to tell us what combinations have we never considered, but we should. Meaning, grab this neckline with that sleeve type and this color and pattern and make us a new style. And we do use algorithms to do some of our clothing that way. We call it hybrid designs. I have another example of this later in the talk. So we have algorithms designing the clothes. And then finally, I have a little nod here to computer science. Any computer science majors here? A couple. All right. So algorithms need to run on some hardware somewhere, right? We use cloud resources, of course, but there's a lot that the data scientists often don't come with a computer science background. And so they're not always the best coders, and they don't know things about distributed systems and so forth. So what we do is we have a data platform team that abstracts the data scientist from knowing the innards of auto-scaling groups and so forth. I'll play this again. So you can see this is our data scientist, and she's writing in very high-level code. She's abstracted from a lot. Her job gets parallelized, distributed, right? So without her having to know stuff. And when one of these machines catches on fire, it automatically moves the job over to another machine, right? So it has this graceful failover mechanism, all abstracted from the data scientist. She doesn't need to know about that stuff, thanks to a great platform team. Okay, I'm going to switch back to the presentation. All right, so that was a long way of saying we have algorithms running in every function of this company. That was only 10. We have much more than that. And they litter in every area of our company. We've figured out ways to leverage more of that data and automate them through algorithms. So the summary of this little mini talk was that new data affords new capabilities. We're not talking about yielding small efficiencies, like small gains. We're talking about wholly new capabilities that add a ton of value to a company. So not just small things, really big things. Cool things about algorithms is they're very low risk. By the time you're trying them, you already know they're going to work. You've already explored a little bit, played with it on some historical data, and you're maybe running A/B tests just to validate that it's going to work the way you thought it would. So very low risk. They usually pan out. And no capital outlays. Other than the data scientists themselves, there's no equipment you need to go buy. It's bits and bytes, and you can do a ton with it that makes you really efficient. I mean, really changing the game here. It flows into your unit economics. Everything works better when you can leverage this data. And best of all, they're defensible. These are hard to copy. Other things like can improve your business, like a good user interface, right? That can change your business. But then your competitor sees it and says, well, I'll do that too. And they can. They can copy your user interface. But algorithms, the IP is usually hidden. You can't see them unless we're talking about them. You usually don't know that we do them. And even if we do talk about them, you usually can't copy them because you don't have this unique data assets, right? You can't, we can even go in, and I joked to my chief legal officer, Scott, when we launched that algorithms tour. He said, hey, Colson, are you sure you're not revealing any secrets here? And I said, Scott, I could go into our competitors and teach this stuff, and they won't be able to do it. They don't have the data assets, and they don't have the data scientists, or even the value system to do these things. It's very hard to bring algorithms into an existing company. I always say you have to kind of do this from the beginning. All right, so that's the end of mini talk 1. How am I doing on time? Ooh, I'm a little behind. I'm going to do this fast, and then 5 minutes, and we'll have 10 or 15 minutes for question. Mini talk 2, humans and machines working together. Okay, so if you've been reading some of these mainstream books, you might be under the impression that machines are going to take over the world and leave us humans without a job. Well, this is not a talk about the competition for jobs between humans and machines. By contrast, this is a little mini talk about how the two can work together to achieve better results than either one alone. So, to make this point, I need some audience participation here. So I'm going to first assert that humans and machines have different abilities. To demonstrate this, I'm going to ask you guys to perform 2 tasks. So I'll reveal the task, and you raise your hand when you have the answer. For this first task, no using devices. All right? You need to test your human brains only. Here we go. Raise your hand when you have the answer. Add up all the multiples of 3. Who's got it? Anyone? No, I'll let you off the hook. Nobody's going to, you all could do it, right? But it seems like a lot of work, like mental work, and it's a pain. I have to hold numbers in my head for a little while. It takes a lot of effort. But a machine is going to do this effortlessly in milliseconds and not complain at all about it. Okay. Task number 2. You're free to use your devices or anything you have on this one. Any machine hardware that you find useful, feel free. Raise your hand when you have the answer. Is the person on your left paying attention? I heard some answers and hands went up. Okay, and your devices aren't super useful in this case, right? So as a human, you had to look and you had to interpret things like body language and social norms, right? And you had to use ambient information. These are things that aren't terribly accessible to machines. They're not great at them. And in fact, in doing so, in doing this task on the right, it was probably 1,000 orders of magnitudes more data than that, right? And yet you did it effortlessly. It took no work at all. You look over and you can make your determination. So you're a much more efficient processor of information of the task on the right than the left. And we'll explain why that is. So I think we're safe to say that a machine wouldn't have helped you on that one. It would help you tremendously on this one. So machines and humans have different abilities. So if they have different abilities, can they be combined to create capabilities that are better than either one could do on our own? Meaning a function or performed by machines and humans is going to equal whatever the machines can contribute plus humans plus any interactions between the two. We get some additive results and potentially synergies. For this to be true, 2 things have to happen. That both machines and humans have non-zero contributions to make, and those contributions can't be the same. They have to be different things. And I think the last test kind of demonstrated those are 2 different things you were doing, and there are some use cases where you need both. Game of chess being an example. Chess was long held as perhaps the ultimate game of thinking abilities until 1997, when Garry Kasparov got beat by Deep Blue, a machine built by IBM. But something interesting happened. Well, first of all, that was not a surprise. This was inevitable, as chess tends to be a brute force game. Computational speed of machines getting better and better. This was inevitable. But after 1997, something interesting happened. Something called freestyle chess emerged. Freestyle chess is when the chess player can use a device of his or her own, usually much more modest than a supercomputer, and they can team up against the supercomputer. And it turns out that even a decent chess player with an average or modest device can beat a supercomputer, because the two are teaming up and they're doing different things to compete with just the machine. Kasparov himself did this, and he said he felt freed up to focus on more creative aspects of the game. And we found another domain that can leverage both machines and humans in the same way. Stitch Fix, we already talked about. We do this in at least three, there's more than this, but I'll talk about 3 different areas or functions in the company. Styling, this is the thing that picks out the clothes for you. I alluded to earlier. So we're trying to assess, is that shirt a good match for this client? And to do that, we leverage millions and millions of data points. So we ship millions of shipments every year. Each shipment has many items, each item has many attributes, and we're sending them to clients that have many attributes. So there's literally billions of interactions to learn from. And machines are going to do that a lot more effectively than a human. They're going to look at all the interactions and figure out things like when they're looking at interactions with that client and different aesthetics, different colors and patterns, we can derive something called a style match. And when we're looking at interactions between clients and sizes and dimensions and different fit parameters, we can assess this thing called fit match. We expose clients to different prices of merchandise, and we can assess a price match and so forth. We also use machines to derive the weights of how much each of those things should matter. We take everything we know from the machines and we distill it down to a single number called a match score. It represents the probability that that client's going to love that thing. But we don't stop there. There's more tasks that we need to perform, but we need to rely on a different processor, a human fleshy type of processor. So we use our human stylists to do things like put the client into a holistic context. They write notes like this one. I need something to wear to my ex-girlfriend's wedding. Okay, that changes things, right? That's a bit of context. It's hard for machines to learn what this means. But to our human stylists, they know exactly. They can empathize. And they say, oh, I know what you're going through, and they will empathize. We also use them for curation. Our machines are trained on the assumption of item independence. It's kind of a silly assumption, meaning the relevancy of this item is independent of what it's sitting next to in the box, the other items. And it's a bad assumption, but we do it for good reason. It's very hard to do. The sparsity of the data gets immense, and it's hard to observe every co-occurrence. And so we allow the stylist to do it. You figure it out. So they put together a nice congruent assortment of items. They don't have to be an outfit, but they have to look good together, and that's one of the roles of the stylist. And finally, they foster the relationship. Our clients like to know that there's actual human on the other side of this. It helps with engagement. It helps with even getting better data. If you've ever interacted with a chat bot, you're very rude to the chat bot. You don't even finish sentences, and you leave them idle for weeks sometimes. But with a real human, you're actually politer. You spell things correctly. You explain yourself a little bit more. And so it helps us get better engagement and better data. So those things, curation, the ability to improvise, fostering relationships, these are things that are in the purview of humans probably forever. And so we need to leverage those in our fixes, and that's why we combine machines and humans. Another example, we talked about this already, so I'll blow through it pretty quick, is fashion design. I already talked about we take maybe a silhouette like that, and we combine it with maybe this lace stitching from the shoulders there, and we'll grab this floral print from that one and create something new, right? And again, I trivialize it here. There's trillions of combinations to consider, but it'll find the ones most likely to result in success. And so our algorithms take on the heavy computational load, the big search cost, by sifting through all those trillions of combinations and recommending to our human designers, here's what we found, here's what we think will work. And then our humans merely need to react to it. Right? Us humans are very good at reacting to things. Do you like this? And in this case, they actually tweaked it a little. They thought that the pattern needed to be a little more blotchy and less symmetrical, and that was our final output on the right. We've done about 120 of these things now, 120 styles designed by algorithms and humans. We call them hybrid designs appropriately, and they're amongst our best sellers. They've been amazing. And we were all skeptical that this would work, but it's panned out very nicely for us. We'll keep expanding the program. All right, and finally, merchandising. This is the process that gathers up the stuff that we store in inventory. We need to keep our inventory very full. We have tens of thousands of things to pick from for every shipment we do. So the more, the better. And what we have machines doing is they're doing the merchandising. So we have algorithms that run that look and see what things that we need to rebuy more of. Right, we're running low, and this is a good thing. We'll sell more of these in the future. So we have the clients to support them. So they're identifying things to rebuy. But we also need to buy new things. We have no data on new things by definition. So when some stuff runs out, and the algorithm said, don't buy any more of that stuff, it's going to run its course, then we need to replace it with new things. And that's where we use the humans. Fashion is a tricky thing. It's always changing. And we need humans out there we call it the marketplace, where they go to all the big shows and they buy things. And they're using their intuition, which is informed by things like who wore what to the Oscars and what's the latest trends they may have observed in some magazine or so forth. And so humans are very good at digesting their surroundings. And so we leverage them for that. So the humans are buying the new things. So algorithms do what we call the rebuys. Humans do the buying of new things. So we're coupling them together in our merchandising. So they're predicting that these funky new styles are going to be out there. So that's just 3 ways that we're combining machines and humans. And this all makes sense. We're leveraging these 2 compute resources for exactly what they're built to do. Machines with their switches and logic gates were built to do rote calculations very quickly. And so that's what we focus them on. Us humans, we were built to react to things, digest our surroundings, and to relate to our other fellow humans. That's what we do really well. This was built in our limbic system, right? This is the oldest part of our brain and therefore the most developed. And that's why we do things like assess whether somebody's paying attention rather effortlessly. We can do that with ease. But analytic thinking is done up here in the neocortex. This is a newer part of our brain and less developed. And this is why it's hard to do math in your head. It's a less developed part of your brain. We don't like doing math in our head. Right? You all kind of rolled your eyes at me when I asked you to add up 9 numbers. But we can do much more complex things with our limbic system. And we like doing that stuff. So by combining the 2, we are able to achieve higher levels of performance than either one alone. And because we're doing more of what we like and more of what defines us as humans, you can argue that we are actually making people more human by ceding the rote tasks to machines. All right, so I'm going to stop there. We have 6 minutes for questions on anything you saw or anything you didn't see either. Question here?
It seems like you guys know what people are buying, but are you able to tell them what's they're actually wearing?
So the question was, we can tell what people are buying, but do we know what they're actually wearing? That's a great question. No, at this point. We always kind of opine about sensor devices or something so we can tell. We are launching a feature at some point. We're exploring a feature that allows them to tell us manually when they wore something, but or if they think differently about something that they once rated highly in the past, because people's tastes change. But at this point, no, we don't have records of what they're wearing. It's a good, another new data set untapped. Let's see, I'll go over here.
Are you tempted to go into other categories based on what you're learning about people's preferences?
So the question was, are we tempted to go into other categories? So we're in apparel. And we started with just women, and then we went into shoes and other things within women's maternity. And then we went into men's, and now kids, and now we're going into UK. So we're expanding, still apparel, but different types of clients has been our strategy. We do joke about this could be useful for a lot of other domains, right? This pairing of machines with humans. I always thought recruiting would be great, right? So machines take on the big search cost of finding you a few candidates, then humans interview them, and then they can make a final judgment, right? So you need both that kind of empirical data plus some judgment. Or fraud detection would also be another one. So we actually talk about Stitch Fix for blank, where we can fill in the blank with whatever you want.
Actually, the other thing that you've learned so much about people that you can predict they want to go on vacation.
Oh, I see. So he's asking about now that we know their preferences for clothes, could we predict preferences for cars or travel plans and stuff? It's an interesting thing. We have not gotten that far. But I do think that there are consistencies across one's lifestyle. If you know how they dress, you can probably guess what movies they're going to like and so forth. It's just a hypothesis of this phase, but it's a good direction. Other questions? Oh, go right there.
How much gets shipped back? How much gets shipped back?
Oh, how much gets shipped back? I can't reveal that because it's proprietary. But those proportions you saw were not too far off of the things coming back. No. Okay, over here.
Have you tried evolutionary algorithms in any of these?
Evolutionary algorithms? Well, the one I described was pretty close. So the one with the designing the clothes. So we're relying on two properties that Mother Nature uses in natural selection, right? Recombination, right? Two parents have offspring and they mix their genes, and then the other property is random mutation. So patterns, we usually use patterns as a random mutation. We have everything else and we just inject a pattern in there. And so that's the closest we've been to genetic algorithms, I'd say. Yeah.
I'm sure you've done this, but can you tell us the difference between the business model and what happens in physical retail? So people like Forever 21 will do something where it's hot very, very quickly, and the selling time is very low.
Yeah.
You don't buy it 2 weeks later, you can't get it. And designers are somewhat similar, knockoffs and so forth. So, there's scarcity factor, all of that. And based upon that, what kind of metrics are different in your business from that business supply chain?
Yeah. So the question was roughly, how does this contrast or compare to what we call it fast fashion? Like fast food, there's fast fashion. That's like companies like Forever 21 and Zara, where they will change things up every 2 weeks, whole new inventory sets, and just trying things fast. I don't know the economics of those companies, but I think there's a lot of spoilage or things that don't work out. They're doing a much higher explore to exploit ratio, right? So they're exploring constantly, and they can respond pretty quickly, which is nice. Like especially at Zara, they're vertically integrated, so they use their stores to try things, and whatever works, they double down on. And there's a lot of failures, but they're not super costly because they didn't make too many units. So it's a neat model, but the downside is the quality tends not to be very good. Especially on Forever 21, word is you wear those things a few times and they fall apart. And that you kind of get what you pay for. The price is low, but they don't last very long. We're trying to do more durable goods, things that will last. There's both a sustainability issue, right? We think it's wasteful to go through all that material. And we don't like to clear things that don't work, so we try to buy good things that people keep for a long time. So slightly different values-based propositions. I can't comment too much on which one's better economically, but it tends to be a values proposition of what you want your company to be. Did I answer your question? We'll go there, red shirt.
What's the process from conception to deployment to modification of a new algorithm in a new space?
Only one question so far I anticipated, and that was the one. Let's see. Well, I'll skip the skill stuff. This is what I said. Okay. So all those algorithms you saw, and there's a lot more than that, virtually none of them were asked for. None of the data scientists got requirements, here's what we want you to build. They came up with them. And that's the cool thing. They have their day jobs, but they're curious, and they tinker on the side. And they end up coming up with all those capabilities. They were not asked for. They came up with them. They found them. They tinkered, and then they proved them out. And then they come to us and say, I think I found something, and we're going to build a capability out of it. So the two things that allow them to do that are these two properties: low-cost exploration. When you have access to the data, you can try things nearly for free. Right? You say, I wonder if I can design clothes by combining successful elements from other styles. And he tried out using historical data, and he said, that looks pretty good. I think I'm onto something, right? Or the data may shut it down, and may say, there's no signal there. And so that's the low-cost exploration. And the second point I just hinted at, evidence. It tells you when you're on the right path. You got statistical measures like AUC, RMSE, et cetera, that tell you, yes, you're on to something here, keep going with this. And there's a lot of failures, right? But they're just low cost. You don't even have to tell anybody, like, I tried something, it didn't work out, it was silly, it took me an hour, and you're back on path. So anyways, the process is something like I just described. Somebody gets an idea, they tinker a little bit, they try something, maybe using historical data with holdout samples, and say, oh, that works pretty well. Their next step is to try it in real life. They allocate themselves, a test cell of, say, 100,000 clients to try it out on. And if that works well, then you're ready to roll it out to production. We got like one or two more. I'll go here.
So my understanding is you have some supplier that ship the item to your warehouse and then you ship it to customer. So why not just eliminate that, or meaning that like you partner up with Macy's or Nordstrom or other suppliers, and then when you come up with a combination for customer, have them ship it to customer. And even better than that, like single books on demand, that the book really doesn't exist. When the customer buys it, there would be a publishing company. Would that be possible to do the same model with this?
So let's see, the question was, we buy from suppliers and we hold it in our warehouses and then we sell it to customers. Why not just connect? And the reason is we like to control the experience. So first of all 5 things that we send you, we want them to come at the same time, not different shipments. And we want them to be cohesive, right? And we even wrap them beautifully, like they're with the tissue paper and they're folded with little notes and stuff. It's all part of the experience. And so that's the reason we want to own this. We'll take possession of the inventory, which is risky, but we get to control the whole experience that way. And also the samples. We get the samples so we can feel the material, measure everything, and all that kind of stuff. And so that's what we decided from the start. And now we're owning this whole thing end to end. It's amazing when you outsource, you lose control. And that may be fine for a very mature business model, but when you're still innovating, you've got to control every part of it. And so that's where we're at. All right, let's go back there.
It seems like it's a fairly unusual subscription service where if you're successful, you're almost putting yourself out of business because you're delighting your customer is deposit full, it's sort of like a dating service. If you're successful, they leave.
Yeah.
So how do you think about continually delighting your existing customers versus going after new customers?
Yeah, so the question was, if we're successful, we'll put ourselves out of business. We'll fill up somebody's closet and then they're done. So you called it a subscription service. I just want to be clear, we're not. You can sign up for something called auto ship, which means you'll get a shipment every month or 2 months, or pick your cadence, but there's no commitment. That's why we don't call it a subscription. It's not a use it or lose it program like a gym membership, right? You pay the membership and you get too lazy to go, you're still out the money. That's not Stitch Fix. If you don't get anything, our incentives are aligned. That's what we like to say. If our clients aren't getting value, then we don't get value. We really don't. We'd rather them end it with us. But to answer your question, so what happens when we get somebody so many clothes, we're so successful that they said, oh, I'm kind of good. That's great, that is success. But clothes go out of fashion and you lose things, they wear out, so you'll be back. And so they do come back. In fact, we are experimenting with slowing clients down intentionally. So we observe some clients are buying an awful lot of stuff from us, and we'll induce this thing. Are you sure you don't want to pause? Like trying to slow them down. And so this thing will pop up. Do you want to pause for like 2 months and let this stuff finally wear? I mean, it happened as an employee. We're all on the highest cadence there is, and your closet fills up fast. And you know you're doing something wrong when you still have closets of tags still on that, right? All right, I haven't gotten to wear these things ever. And so that's when I'll manually pause myself. But it's good to get the recommendation too, say, hey, you might need to slow down. So we are experimenting with that. We're not clear if it's a good thing or a bad thing yet, but sometimes it can be a helpful nudge that clients need. All right, how are we doing on time? Okay, so I think we'll cut it there. I am going to stick around after if you want to ask questions individually up here. So I'm happy to stick around for another 30 minutes.
And just one other